We now state Coulomb's law. So suppose you have 2 points, both these points are charged. So force between 2 point charges or 2 points which are charged is directly proportional to the product of the charge and inversely proportional to the square of distance between them. So you have 2 point charges and we are going to give the formula for force between them. So the force is given as, so this is the magnitude of the force is K times Q1 times Q2, take their absolute value divided by R square, where R is the distance between the 2 point charges Q1 and Q2. Now absolute value means you just ignore the negative sign of the charge. You just take the positive charges. If there is negative, you just ignore it. So K is a proportionality constant. You write it as 1 over 4 pi epsilon 0, where epsilon 0 is called permittivity of free space. So experimentally, this epsilon 0 is determined to be 8.854 times 10 to the power of minus 12, and its units are Coulomb square divided by Newton meter square. The units have been chosen so that after cancellation we just get newtons, which is the unit for the force. Now you plug this in the formula for K and you get K as 9 into 10 to the power 9 newtons. Now we are just drawing the figure for the force. There are 2 charges, Q1 and Q2, both of them are point charges and they're separated by a distance R, and the force between Q1 and Q2, the magnitude of the force is given as K times Q1 Q2 absolute value divided by R square, and the proportionality constant K is 9 into 10 to the power 9 newtons. Now we discuss an example. So in this example we have 2 charges. We have charge Q1 as 1 Coulomb, charge Q2 as minus 1 Coulomb, and the distance between these 2 point charges is 1 meter. So the force is given as K times absolute value of Q1 times Q2 divided by R square. Now R is 1 meter, so you divide by 1 square, and this will just give you K, because you're taking absolute value of minus 1 is just 1, and this gives you force as 9 into 10 to the power 9 newtons. Now we want to compare this electrostatic force which we just talked about with the gravitational force. Now at the atomic level, electrostatic force is much stronger than the gravitational force. So we will see this with an example. So say we are given mass of proton as 1.67 into 10 to the power minus 27 kgs. So this is the mass of a proton which we measure experimentally. And mass of electron is given to us as 9.11 into 10 to the power minus 31 kgs. Again, mass of electron is determined experimentally. So we know the masses of proton and mass of electron. Now the electric force is given as K times absolute value of Q1 Q2 divided by R square, the magnitude of the force, and the gravitational force is given as gravitational constant times mass of proton times mass of electron divided by R square again, where R is the distance between proton and electron. So the charge on the proton Q1 is just E, charge on the electron is minus E. So the force, you just plug in value of Q1 and Q2, the force you get is K E square over R square is the electric force. So the ratio of electric force over gravitational force is just K E square divided by gravitational constant times mass of proton times mass of electron. So notice that R square just cancels out. Now you just plug in the values. We know the value of K we know the value of E, and we know the value of G, MP and ME. So once you plug in, you get 2.4 into 10 to power of 39. So that is the ratio of electric force to gravitational force. So you can see that electric force has much more magnitude than the gravitational force.